Okay, understanding one-to-one functions. A function is a special relationship where each input has a single output, and we can see this in our first mapping. A relation that maps one input to different outputs is not a function. For example, the following is not a function. I can see -2 is mapped to 8, and it's also mapped to -6. So that is not a function. In my next mapping here, I see an example of a function that is said to be one-to-one. Each y value is paired with exactly one x value. In my last mapping here on the screen, I have a relation that shows a function, but it is not one-to-one because the y value -6 is paired with more than one x value. I have 0 mapping to -6 and 1 maps to -6. So be sure you understand the difference between determining whether something is a function and whether it is a one-to-one function. We're going to look at 3 different ways of how to tell if a function is one-to-one. Well, the first way that we're going to look at is with a table. When you have a list of ordered pairs, it doesn't have to be at a table form, it could be in set notation form. The y values do not repeat if your function is one-to-one. So here you can see my y values repeat. This is not one-to-one, and in this table, all of my y values are different, so this is one-to-one. In my next explanations here, I am looking at graphs, how to tell if a graph is one-to-one. If you remember that when we were looking at graphs of functions or relations and determining if they were functions or not, they had to pass the vertical line test. Well, in order to determine whether something is one-to-one, it has to pass the horizontal line test. If I can draw a horizontal line and it passes through my graph in more than one spot, it is not one-to-one. In this graph over here on the left, every horizontal line I would draw is only going to hit my graph in one spot, so that is one-to-one. Now, if I'm given an equation, you want to figure out if the graph or if the equation is one-to-one, then I can put that equation in my graphing calculator to graph it and then use the horizontal line test. Now, if a function is one-to-one, it is said to be invertible, or that it has an inverse. That means there's a relationship that maps the range of f of x to the domain of f of x. And this new relationship is notated with this inverse function. This is not an exponent of -1. It looks like it, but don't get that confused with an exponent. Here I can see my f function maps the x to the y, and the inverse function just maps them back again. And with my next set of mappings here, I can show what an inverse function will do. If I have a function f, it will map a to 3. The inverse would map 3 back to a. And that is for every x and y in your domain and range.